In this lesson, we're going to go over the properties of logarithms, and we're going to use these properties to condense, expand, and simplify logs. So there are three main properties, and the first one is the product property. So if we have a log of something that is being multiplied together, we can split it up by using addition in order to expand it. So first, we're just going to focus on expanding. So let's look at an example here. We have log of 3xy. So the 3xy are all combined together through multiplication. So I can break this up into addition. So what I'm going to do here is write it as log of the first number, which is 3, plus log of x plus log of y. Okay, so since there's three things that are being multiplied together, I'm going to have three separate logs. Okay, so when you're expanding, you start out with one log, and you should have as many logs as you need to have. So in this case, there's 3 because there's 3 things being multiplied together. And we would have addition signs instead of having multiplication. Now, if we wanted to condense it, we can go the other way. So looking back at the property up here, the main thing is that the base needs to be the same in both of these. So as long as the base is the same and we're adding, we can multiply what comes after the log in order to condense it. So in the first example here, ln of 6 plus ln of x, ln is your natural log. So it's a log with a base of e. Everything that we're going to be doing with logs is exactly the same for natural logs. The only difference is that we write an ln instead of the word log, but it's the same thing. So when I look at ln 6 plus ln x, okay, the base on the ln is e, so they have the same base. Because I'm going to be adding here, that means I need to multiply. So I'm going to multiply the 6 and the x. We start out with 2 logs here, so when we're condensing, we should only end up with the word log or ln written one time. So this would be ln of 6x. Okay, and let's look at this last one here. So log base 6 of 12 plus log base 6 of 3. So again, notice that the bases are the same. Now we know how to evaluate logs, but we don't know necessarily what this is, right? Log base 6 of 12. If I try to think of 6 to what power gives me 12, I can't. 6 to what power gives me 3, I can't, right? It's something we would need a calculator for. It would be some type of decimal. But we can use our product property to kind of simplify this first by condensing it and then see if we can evaluate from there. So I'm going to add, which means I'm going to multiply. So I get log base 6 of 12 times 3. So I'll just write it out like this so we see where it's coming from. So this is really the same thing as log base 6 of 36. And I can actually evaluate this now. 6 to what power is 36? Well, this is just going to equal 2. So by using the product property, we can get a log that we can actually simplify and evaluate without having to use a calculator. Okay, so product property, if you have multiplication, it goes hand in hand with addition. The second property is the quotient property. So if we have division, that's going to go hand in hand with subtraction. So if I have a log of m divided by n, I can break it up into the log of m minus the log of n, and again, the bases would be the same. So let's look at this expansion problem. So we have the ln, which is our natural log, of 7 over x. So we're going to have the ln of 7 minus the ln of x. Because we're dividing 7 and x, we're going to subtract. And again, when we're expanding, we should have more than one log or ln written. Okay, when we are condensing here, because we have subtraction, we know we're going to use division because they go hand in hand. We check that the bases are the same. These are both common logs. The base is 10, so we're good. So we're going to write the word log one time, and then we're going to divide the x and the y. So x over y. Okay, and same idea for this one here. So similar to when we looked at the product property, 2 to what power is 96? 2 to what power is 3? Can't really figure that out without a calculator, but let's see what happens when we actually condense this first. So check the bases. They're both 2, so that's good. So log base 2, and we're going to divide 96 and 3. So 96 over 3. So that's the same thing as saying log base 2 of 32. And 2 to what power is 32? That would be 5. So we can actually evaluate this now because we've condensed it and make it a little simpler. The last important property is the power property. So that's saying that if you have a log of something that has an exponent, the exponent can be brought down in front of the log. And same thing for the other way around for condensing, but we'll talk about that in a minute. So for expanding, I have log of x squared. I have an exponent of 2, so I can bring it down in front, and this will be 2 log x. For condensing, I have 3 ln y. So the 3 in front means that it was an exponent, so I'm going to bring it up as an exponent to the y. So I'm going to have ln of y to the third. Okay, so let's put all these together. So for number 1, expand each expression. So we look at this and we see that the 5x cubed y, they are all being multiplied. So I can break this up with addition. So first I'll have log of 5 plus log of x cubed plus log of y. Now I want to notice if there's anything else I can do. And here I see that I can use the power property because I have x to the third. So that 3 can go down in front of that log. So we'll end up with log of 5 plus 3 log x plus log y. And that is fully expanded. So again, when you're checking to make sure that it's fully expanded, you want to make sure that you have the word log written multiple times, that you have addition or subtraction and no multiplication and division, and that any exponents have been brought down in front. So let's look at number 2. So here we have the natural log. We have that ln, and we have division going on overall. So we can write this as the ln of the square root of 3x minus 5 minus the ln of 7. Now the square root of 3x minus 5, anytime that we have a square root, we want to make sure, or any type of radical, we want to make sure that we change it to a rational exponent, because then we can use the power property and bring it in front. So what I'm going to do here is just rewrite this as 3x minus 5 to the 1/2 power minus ln 7. And then the 1/2 power can go in front. So I have 1/2 ln of 3x minus 5 minus ln of 7. Okay, so that would be fully expanded now. Again, we have the word log or ln written multiple times. We have addition and or subtraction, and we have exponents down in front. So let's look at number 3. So we've got a log, and we have overall division, but in the denominator, there's multiplication happening. So let's say that we have the log of the square root of y minus the log of the whole bottom, x to the 4th cubed root of z. Okay. Now this piece we can break up using addition. However, because it's in the bottom, it's going to stay with this negative. So let me just rewrite this like this. So it's negative. I'm going to break this up now with addition. So log of x to the 4th plus log of cubed root of z. Because I have this negative on the outside, it's getting applied to both. So both the log x to the 4th and the log cubed root of z will be negatives. And kind of like the shortcut is that if it's in the bottom of a fraction, it will be negative. If it's in the top of a fraction, it will be positive. Okay, so you can write it the way I'm writing it. I'm just kind of showing this to show you why it's going to both be negative, because even though we're adding, it's in the bottom, so it's technically negative. So next thing I'm going to do is I'm going to change all of my radicals to rational exponents. So I'm going to have log of y to the 1/2 minus log of x to the 4th. And then I'm going to make that negative by either distributing this negative in or realizing that it's in the bottom, so it's going to be negative. And this will be log of z to the 1/3. So my last step is going to take all my exponents and put them in front. So I'll have 1/2 log of y minus 4 log of x minus 1/3 log of z. And then that would be fully expanded. Again, we have the word log written multiple times. We have addition and or subtraction, and we have all of our exponents brought down in front. All right, so the last one we have here, again, we have overall division. So I have log of x cubed square root y minus log of z squared. The x cubed square root y are being attached through multiplication, so I'm going to break that up using addition. So I'll have the log of x cubed plus the log of the square root of y minus the log of z squared. And again, the little shortcut is if it's in the top of your fraction, it'll be positive. If it's in the bottom, it's going to be negative. Since the x cubed square root of y are both in the top, they are both going to be positives. Okay, I'm going to change my radicals to rational exponents. So we have log of y to the 1/2. And then I'm just going to bring all of my exponents down in front. So 3 log x plus 1/2 log y minus 2 log z. And there we have a fully expanded expression. Okay, so now we're going to go the other way where we're going to condense. So we're basically doing the complete opposite of what we just did. Okay, so if we look at the first question, 1/2 log x plus 3 log x plus 1. So what I'm going to do here is, first thing I'm going to do is take any exponents and bring them up back to be exponents. So this 1/2 is in front. That means it's the exponent on the x. So this will be log x to the 1/2 plus this 3 is going to go up as an exponent. So log x plus 1 to the 3rd. Okay. The next thing I'm going to do is, if I have any rational exponents, I want to change them into radicals. So I'm going to change this x to the 1/2 and make this log square root x plus log x plus 1 to the 3rd. Okay, I have the same base on the log. They're both bases of 10 because they're that common log. I'm adding, so what I'm really going to do is multiply the square root of x and the x plus 1 to the 3rd together. So I'm just going to make this log, and I'm going to have square root x times x plus 1 to the 3rd. And I'm just going to leave that as my answer. I'm not actually going to like FOIL anything together. I'm just going to leave it like that. Okay, so when you're condensing, your final answer should only have the word log or ln written one time. You should have multiplication and or division. You should have exponents and or radicals. So it's literally the complete opposite of when you're expanding. So let's look at number 2. So same idea, I'm going to take any numbers in front and move them up as the exponents. So this will become ln of x plus 2 to the 3rd minus ln x. And then I have subtraction, which means I'm going to be using division. So I'm going to write the word ln one time, and I'm going to have the x plus 2 cubed on the top since it's positive, and I'm going to have the x on the bottom because it's negative. And there we have a fully condensed expression. Okay, there are a few more properties that are good to know. They come up sometimes, so here they are. You can kind of write them down. If you change forms, they kind of make sense as to why. So I'm just going to walk through this real quick. So if I change forms here using my little counterclockwise circle, I would have a to the 0 equals 1, which makes sense because anything to the 0 power is equal to 1. Okay, so we get that. For the second one, we have, again, if we change forms, we would get a to the first is equal to a. Right? That makes sense because anything to the first power is going to be itself. Then we have this one here, and again, change forms. So a to the x equals a to the x, which again makes sense because anything is going to be equal to itself. So the little shortcut here, if you're looking at this log example, log base 2 of 2 is 7. These pretty much are going to cancel out. So you end up with just 7. So that's kind of a little shortcut, is when the base and the number next to it are the same, they're going to pretty much just cancel out. And then this last one looks a little weird. A to the log base A of x equals x. So this is really in exponential form. So if I wanted to change it to a log, I would have log A is going to be my base, so log base A of x equals my exponent, which is log base A of x. And what do you know? It's the same thing. So if it equals the same thing, obviously that is going to make sense. So if you look at this example over here, as long as the base of the exponent and the base of the log are the same, again, that's going to kind of just cancel out, and you're going to be left with whatever's next to the log. Okay, and then lastly, if log base A of x is equal to log base A of y, if they're exactly equal, then x has to equal y, which again makes sense because the bases of the logs are the same. So if the values are equal, the numbers next to the log must also be equal. So these properties don't come up as often as the main three, the product, the quotient, and the power. So let's just look at a couple of examples real quick. Okay, so we have log of 6x plus 5 to the log base 5 of x squared minus log of 12x. So we just want to simplify this. So I'm going to keep this as log of 6x. Okay, there's no property I can really use there. But this 5 to the log base 5, that's going to pretty much cancel out. So that's just going to be x squared. And then minus log of 12x. So using my other properties of the quotient and the product and the power and all that stuff, these two, because they are logs, we can actually condense together. The x squared, since there is no log attached to it, we can't do anything with that. So the log 6x is positive, the log 12x is negative, so that means I'm going to use division. So this would be log of 6x over 12x plus x squared, because that's separate. And I can simplify 6x over 12x, and that's just going to be a half. So I end up with log of 1/2 plus x squared. And this would be fully simplified. Okay, and for number 2, we have log of 100 plus 6 log base of 6 of 19 minus log of 1. So log of 100, we actually know what that is because the common log has a base of 10. So 10 to what power is 100? Well, that's just going to be 2. 6 to the log base 6 of 19, that's that other property because the bases are the same. This is just going to be 19. And then we're going to subtract the log of 1. So again, common log has a base of 10. 10 to what power gives you 1? Well, that's that little property that's going to be 0 because 10 to the 0 is equal to 1. So when I combine this, I end up with 21 as my answer. Okay, so for homework, you guys are going to try these 4 problems and you're just going to practice expanding and condensing some expressions.